be a good one to start with again for number 4. So, refreshing our memories from Friday, the first thing that we're going to want to do is we're going to want to go into a new document, especially if it's one of our calculators. You definitely want to start a brand new document every single time. Don't want to save it, but start a new document, and then we are going to go into a graph. Okay? Problem with the graph is when you just go into the basic graph, that currently is a function graph, and so it would only do one. We want to graph a parametric, so we are going to go into Menu, Graph Entry Edit, and we want parametric. Okay. What that does for us is the input area on the parametric equation, or on the graphing calculator, now has it in parametric form, so we can put in our x value and our y value and our t step. So our x value from number 4 again was t cubed minus 3t plus 1. T cubed minus 3t plus 1. So we're going to go t cubed. Got to get off of the exponent, minus 3t. The negative sign here is not the same as a minus sign. Okay? Plus 1. That's our y function. That's our x function. Our y function is 2t. So we scroll down here to 2t. Then it said to graph t over the interval negative 2.5 to 2. So I have to change my t values here to negative 2.5 and this one to 2. T step, just as a reminder, that's how often it's calculating it. So it's going to calculate it every 0.13 or 10 times every, or roughly, let's say 9 times every unit. It'll make these calculations. Okay? Then when you hit enter, you should see the graph. If you don't see the graph, then we can adjust it to figure out so we have a full graph right there. Okay? The nice part is also we can go through and we can trace. So if I needed to copy this over onto an actual graph, if this were next, or I shouldn't say next week, because where are we at? We're at this week, so we're at 2 weeks from now, 2 weeks from tomorrow. If I wanted to trace this, I could graph trace. Actually, I would set my trace step at 1, just because it makes it easier. And then I could trace, graph trace, and now, so it has it here at my t value of negative 2.5. And then there is the corresponding point. Okay? And then if I scroll to the right, it's going by ones. So at a t value of negative 2, I would graph the point negative 1, comma, negative 4. At a t value of 1, here, hold on, let me get this out of the way. At a t value of 1, come on, oh, because I'm graphing, or I'm tracing, I should say. At a t value of negative 1, I'm at the point 3, comma, negative 2. At a t value of 0, I'm at the point 1, comma, 0. At a t value of 1, I'm at negative 1, comma, 2. And a t value of 2, I'm at the point 3, comma, 4. Okay? And then that way you can easily transfer your calculator graph to your actual Let's look at Tony and Sue. Tony and Sue are launching lawn darts 20 feet from the front edge of a circular target of radius 18 inches. Sue throws the dart directly at the target and releases it 4 feet above the ground with an initial velocity of 25 feet per second at a 55-degree angle. Trying to find a ball that I could use. There we go. Okay. So she's got a lawn dart. Okay. She's releasing it, and it's going off and it's flying. Okay. It's going to go up and out. Then what's going to take effect on it? Gravity is going to take effect on it, so it's going to make an arc, and then it's going to come back down, and her goal is to land it in the 18-inch radius circle 20 feet away. Okay? The parametric equations that model this situation are below. Okay? So, first off, need to make sure that your calculator is in degrees, because we're dealing with degrees here. So you need to switch this to degrees. Take your cursor up there, click on it. Okay. So now we need to put in those ones. So we've got 25 cosine of 55 degrees. 25 cosine is located under trig, 55 degrees, and then outside of that parentheses, we need to have a t. Inside is going to mean something totally different. Outside, we need it. That's it. Then, negative 16t squared plus 25 sines of 55 t's then plus 4. When you hit enter, you should see here's the lawn dart being released at 4 feet, but we don't see anything else. So let's logically think about this scenario. Because we don't need to zoom out, we can manually do this. Okay? In terms of x's, how far out do we need to go? Where is our target? The target is 20 feet away, right? Okay. So if we went out to 25 feet, we should be able to see the entire graph. Yes? Okay. So I like to see my axes, so I'm going to go negative 5 to 25, and I'm going to go by ones. Okay, that's my horizontally. She released it at 4 feet. How high do you think this is going to go? 5 to 10 feet, maybe? So 15 should be enough. Okay? So once again, I'm going to go negative 5 to 15, and I'm going to go by ones. Then when I hit enter, now I see the whole flight of this lawn dart. My T-step, as long as it doesn't, so if I put a T-step here of 2. Oops. So that means it's in the air for less than 2 seconds. If I put a T-step in there of, trying to get a T-step where it doesn't go. There. So if I put a T-step in of 0.5, she releases it. Half a second later, the dart's just hanging there in the air. Okay? So as long as I get it so that it hits the ground, we're okay with that. Later on this unit, we're going to be able to figure out just exactly when the object, if you will hit the ground. We'll be able to solve this equation to figure out when it hits the ground, where it hits the ground, maximum height that it got, how far out was the maximum height, all that fun stuff. That's what we're going to get to on this. Okay? So we've got that. Now, the question is will she hit her target? So what were the parameters of the target? The front edge of the circular target is 20 feet from her. Okay? So the front edge is at 20 feet, right? Okay? So here's how we build that parametrically. I'm going to hit tab. Come on now. I'm going to hit tab. And I want to be out 20 feet, right? So I'm going to put 20 in for my x. And I'm going to leave it as 20. Okay? I want to be able to see this ring, though. So in my y, I'm going to put t. And then down here, for my t-step, I'm going to put 5. That's going to build me a 5-foot wall 20 feet away. Ready for it? There's my 5-foot wall 20 feet away. So that's signifying the front edge of my ring. Bless you. Everybody understand me on that? Really, the wall's not there. I just need to be able to see where the front of that ring is. And if I just put a dot there, I probably won't be able to see it. Okay? Then, now I got to put the back side of the ring. How far away is the back side of her ring? How much? In feet. Per feet? So how far away from her is it? Is what I'm asking. How far away is the back of her ring? It's an 18-inch radius. So 23 feet away is the back of her ring. Because it's an 18-inch radius, so it's a 1.5-foot radius. So we have 2 radii to make a diameter, which means it's a 3-foot diameter ring. Oops, wrong one. Tab. So now I need to go out 23 feet, Once again, I'm going to build a wall. So that's going to be T. And because I'm symmetric, I want that wall to be 5 feet there. So there is the ring. Did she hit the target? Yep, because it landed in the ring where it hit the ground. Here, now let me get a screen capture here. And then so here is the ring on the ground. She hit the ring, so yes, she did hit the target. Okay. On Friday, what you're going to be doing is you're going to be doing something similar to this, where you're going to be launching a steel ball, a ball bearing, if you will, from over there by where the stop sign is, and you are going to land it. You're going to put it through a ring at its apex, at its peak, and you're going to land it in one of 3 sizes to choose from. And the more points you get is depending on how small the size that you choose. Okay, so there's a soda can bottle cap, there's a Gatorade bottle cap, and then there's like a Tupperware sized bottle cap, okay, that you can land in, and you get more points for the smaller that you get. So this week, Friday, what you're going to be doing is you're going to be doing all the math behind this, and then next week, Friday on the 16th, you're going to actually be doing the launching. Okay. Any questions on today? That's all I got for you today.